right, just a few more examples from section 3.4, and I will write that up here also if you're referencing sections in your notes. And there's two examples, and we don't have to fully do them. I think probably one example was enough, but I just want to make sure you understand what maybe no solution or infinitely many solutions look like. So looking at this first example, it has a system of three equations, three variables, x, y, z, and of course your first step is to pick out which variable would be the easiest to eliminate. And it probably jumps out at you like it does to me, but right away these x's will eliminate if I put equation 1 and 2 together. These x's will eliminate if I put equation 2 and 3 together. Y wouldn't be any more challenging, nor would z, but x is just as is. I don't have to change a thing. So I'm going to label these equations. I'm going to call them A, B, and C. So first and foremost, I'm going to put together A and B. So if I rewrite, I should say, A and B, and add those together, of course the x's eliminate. Negative 2y plus y is negative y. Negative 2z plus z is negative z. And 13 minus 9 is 4. Okay, so that was equation, sorry I told you I'd label these in A and B. Now I'm going to put together B and C. So, and actually, you know what, I'm just going to go up here and put together B and C. So I'm going to add together B and C. The x's eliminate. Y minus 4y is negative 3y. Z minus 4z is negative 3z. And negative 9 plus 21 is 12. So I'm just going to select a different color here. This equation and this equation now is a system of equations with two variables, which I can turn around and do elimination on. So I don't think it really matters. If I want to eliminate y, I could multiply this one by negative 3. If I want to eliminate z, I could multiply this by negative 3. So it looks like I'm multiplying by negative 3. So I'm going to take this equation times negative 3. So that's going to be positive 3y plus 3z equals negative 12. And then I'll just align this equation down here. So I'll rewrite that. Negative 3y minus 3z equals positive 12. And I'm sure you see what's happening when you add the y's, you add the z's, you add the 12s, everything cancels out, and you have the identity. So this is an example of infinitely many solutions. Some things may occur. I just want you to understand that, you know, we had to take it all the way down pretty far to get to the identity. Every once in a while it happens in the very first step, and don't be alarmed if that happens. That's totally fine. So there's an example of infinitely many solutions. So this means, you know, you have, you know, three parallel planes in space. I'm sorry, not parallel. Three planes that are on top of each other, so they share every possible solution. Now if we go over here and look at number 2, and I think, well, take a second and you decide what you think would be the easiest one to eliminate. I'm going to erase my 2, put it up here. And I'm going to call these A, B, and C again. And I would say probably the Y looks to be the easiest. So I'm going to put together A and C for obvious reasons. So I'm just going to actually just put here because I think you can follow along. I'm going to add A plus C, but I'm not going to rewrite those so I don't waste your time. So adding A plus C, I get a 5x. The y's cancel out. I get minus 5z, and 7 minus 2 is 5. Then let's see, I might do B and C. So if I do B plus, I'm going to do B plus, but I'm going to double C, so I'm going to write 2C here. And okay, so I'm going to double C as I go. Actually, maybe what I'll do is overwrite C. So if I double C, this is going to be a 6, this is going to be a 4, and that's going to be a 12, and that's going to be a negative 4. Nope. That's a huge mess, isn't it? Scratch that. I will just rewrite. How about that? All right, so b plus 2c is going to be, here's equation b. And if I double c, I'll have 6x plus 4y minus 12z equals, oh, I have to erase this again. This is just not going I planned. Okay, so equation B is 4x minus 4y plus 2z equals 17, doubling c. Alright, now when I add those up, I get a 10x. My y's cancel out. That's supposed to be y. Minus 10z, and 17 minus 4 is 13. Now, clearly, you can see the same situation, but slightly different, is going to happen. If I take, use a different color here, this equation, and double it, okay, so I'm going to have, and multiply by negative 2. Okay, so I'll have a negative 10x plus 10z equals negative 10. My x's and y's cancel, or my x's and z's cancel out, but 13 minus 10 is 3. So I don't have the identity, but I have a false solution. So this example 2 is an example of null solutions. So bottom line, don't be alarmed if your variables wipe out on you. It's just either infinitely or null solutions. Alright, this last example I'm not going to work out because I hope that you understand the process, but I want to just go through a word problem because I always think that that's good practice regardless of what type of problem you're working out. So I'll give you a second to read the problem. You have $30 to spend on picking 24 pounds of 3 different types of fruit at a farm. The apples cost $1.40 per pound, blueberries are 90 cents per pound, and the cherries cost $1.10 per pound. You want twice as many pounds of apples as the other 2 fruits combined. Write a system of equations that represent the situation, and then we won't solve it. Alright, so again, what can vary? Well, you have apples, blueberries, and cherries that you're purchasing. The only thing that will vary, because you have a fixed amount of money that you want to spend, you have a fixed amount of pounds that you want to purchase, and you also have this stipulation down here, twice as many pounds of apples as the other 2 fruits combined. So really the only thing that can vary is the amount of fruit, the pounds of fruit that you purchase to make all of that happen. So of course I would define my variables, and I'm going to use A, B, and C for apples, blueberries, and cherries. You can use any variables, of course, right? So A would be the pounds of apples, and B would be the pounds of blueberries, and C would be the pounds of cherries. So I have $30 to spend on picking 24 pounds. Well, I know that I want 24 pounds total. So that first equation probably is not too tricky because you want a total of 24 pounds and your variables are in pounds. So pounds of apples plus pounds of blueberries plus pounds of cherries should equal 24 pounds. And again, make sure all your units match up, pounds, 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 all the way across. So there's equation 1 that takes care of that kind of stipulation. I have $30 to spend. Well, I can't say A plus B plus C equals $30 because A, B, and C are pounds of fruit and 30 is in dollars. So of course I'm going to stick the dollar amounts in front of the variables. So for apples it's $1.40 per pound. For blueberries it's 90 cents per pound, and cherries are $1.10 per pound, and I have $30 to spend. So money, everything's in units there for dollars. That takes care of that. And then the last sentence says you want twice as many pounds of apples as the other 2 fruits combined. So the other 2 fruits combined, of course, would be blueberries and cherries, and combined means add them. And I want twice as many pounds of apples as the other 2 combined. So twice that should equal apples. So, well, that's the equation, but I'll rewrite it down here. Now, If you, I'm not going to solve this, but if you were, I think a red flag might be is that this last equation is not in standard form like the others. Notice A, B, C all on one side here, not the case. Don't be alarmed, that's not, it's not a difficult thing. I mean, if you distribute the 2 through, of course you get 2b plus 2c, bring all the variables over to the left-hand side by subtracting them and set it equal to 0, and you've got it in standard form. If this were a... Sorry about my phone ringing. Oh, it's a pleasant interruption. But anyway, so when you're setting up these 3 equations, you could, if this were on a test, obviously because of the decimals, this would be a calculator problem just because you'd spend so much time, you know, trying to figure out what to do with those decimals without a calculator. So no worries there.